Okay, Motmot, you are a super plumber.
Yeah, pretty much. Yeah. So I'm the chief engineering officer up
Okay.
there, and my job is basically forging the path forward on like our critical tech milestones to get these robots in the pipes.
And that's,
Right.
I mean, it is kind of just that simple. You're building robots that can go into pipes, and the obvious for most robots and industrial stuff that is an assembly is inspection. So is that like your main focus?
Yeah. So these actual robots, like we refer to them as inspection tools, and then like the general business model is going to be like hardware as a service. So we are providing these little robots plus their accoutrement to be able to get the municipalities to get eyes inside of the pipes. Like, what are they actually looking at, right?
I'm so looking forward to this conversation. Infrastructure and honestly, like pipes in particular, like super interesting to me.
Yeah.
First question I have, because I'm immediately thinking of like the robot pills they make you swallow after you're 40 to check if there's if you have colon cancer.
Yep.
Do you recover the robots after, or I would presume that is the hope, but you lose some? Like, how does that work in practice?
So right now, we've never lost one.
Okay, well,
So yeah, right now, like how we're starting off is like we have these like tether managers that like so they have to be tethered while we're
you can winch them. That
exactly, yeah. If they get jammed, we can drag them back out. Long term, like they will stay inside of the pipe. So the inspections typically are going to be happening like at 2 a.m. because you think like over the course of the day, like when do you use the most water, right? When you brushing your teeth, taking a shower, flushing the toilet, right? And then when you come home, you're getting dinner on. That's when the velocity in the pipes is really high. So in order to like limit our battery usage, we stash the robot during those times.
you're creating a fleet of little tiny robot Morlocks that like live under the city.
You got it. Yep. So, but interestingly, this comes with a whole bunch of like different technological challenges. So, one of them, no GPS, right? So typically, if you're running, field robotics, you're going to have GPS, some sort of like navigation system. We don't have that. So we got to come up with something new. Another one is SLAM algorithms. So SLAM is simultaneous localization and mapping. So if you just drop a robot in a spot, like how does it build up an understanding of like, this is the room I'm in and where am I in that room, right? So in this particular case, our pipes, our localization and mapping is actually quite a bit simpler because it's a pipe. It goes from here to a joint to here to a joint.
Right? A Zork map. It's like
yeah,
90 degree angle.
You got it.
Going this far. Yep. Let's talk about hardware for a little bit because it's super interesting. Like, do you have just one size now, like one diameter for these, or do you have different models already?
So right now, we're basing it off of like an off the shelf Blue Robotics hull. So Blue Robotics is a company. I'm also I'm a student at U of M and I work in the field robotics group down there. So like we build submarines to do whatever, right? And then, we use the same hardware to build submarines that go look at shipwrecks or to like go inside of the pipelines, right? So at the spot that we're in, like we are using a standard like 6-inch hull for the pipeline inspection robots.
And there's more, tell me, but like I would presume the two main types of pipes that like a municipal client or a city would use are potable water and black water, like sewage and water. Are there other major like fluids getting moved around under a lot of our cities?
Natural gas, but that's out of spec. And then you have somewhere like Detroit, these old places will have steam lines. But because we're swimming, it's pretty much going to be only potable water.
Okay.
Because your sewers, like they're not actually filled with sewage the majority of the time.
It's not pressurized usually.
Yeah, exactly. Hopefully,
yeah.
This is something terrible.
That's my startup. Is I'm going to pressurize the sewer system. I don't know what the second step will be, but innovation takes
question mark,
yeah.
Right.
All right. Well, how far along is the company? And then I want to talk a little bit about like why, right? Like in a basic sense, if you run a a water supply for anything. Like, it's good to know if your pipes are cracking or leaking and all of those things, but the money is got to be a factor too, if you're operating those things. And I mean, if it's from, Flint around here is like a recent, relatively recent example, but I see it in stories all the time of like, a city all of a sudden realizes they've been shooting 100,000 gallons out of the side of some pipe, halfway in a subdivision. Like, how common is bad piping as a problem that people are just ignoring entirely?
It's actually it's a really prevalent problem, and the main reason is because you can get away with it being broken for so long, right? Because if you have a pipe that's like corroding through, when it starts to leak, it's not a catastrophic leak right from the get-go. You're not flooding out a city block, right? It's like that leak that flooded out that neighborhood here was probably leaking for years before that. They just didn't know, right? And because this, the solution, if you have a small leak today, is just pump a little bit more water, which is basically free here in Michigan. Like, why would you not?
Yeah.
Right. And it's not until something catastrophic happens that people start looking around and saying, oh, that's terrible. Why didn't we catch it?
So before we go kind of into the problem a little bit more, like, let's keep talking about the robots. You're using a platform for them. Like, how long? They fit in a 6-inch pipe, so they're smaller than the 6 inches. Like, powered all through the tether as well.
So that's something that we're working on right now. They are battery powered at this point. So we take them out, we charge them up. They've got like a Nexus unit that we use for like chlorinating, right? But my current project is I'm working on using those same tethers that we use for communication. So, one thing to keep in mind is like the tethers that you see when they're driving those like little submarines around, they're generally just communication. So if you have like an off-the-shelf like inspection robot that goes down there, they have batteries on them and you're only transmitting back communication over the wire. And that's just a function of like the power to get over that wire, right?
Plus with water and even and ground or whatever, like radios barely work in most cases. So like that's the one thing, if you want a real-time signal, you got to have a wire.
Yeah, or a fiber. So like the Nereus, like the submarines that go underneath the ice shelves, like they have like a brass canister that feed out like a single glass unshielded fiber, and that's how they communicate with it. And then the robot has like some fail safe, like, okay, if I lose communication, like come back this way.
Which also not to get into drone warfare, but people in the Ukraine-Russia conflict, as the drone war continues to ramp up, and there was these pictures of like birds nesting with unshielded fiber optic cable, or fields covered to look like spider web.
Exactly.
People, if you've ever wondered why that is, it's the same solution for the problem in the reverse, which is those are drones flying through the air. They absolutely could use wireless communication, but then that could be jammed. And so the way a lot of that stuff works, and this is not actually a new technology, it's the same way tow missiles and stuff had worked for a long time, is it's like a fishing line or a reel, and it shoots out a little thread of glass, and you can put a bunch of data up and down that glass. So on yours, and then on the mechanical side for the tether, because if you're basically, are there motivators on the device? Like, are they? I guess there have to be. Like, how does it get around?
So there's 2 thrusters on either side. And then pitch control is pretty much maintained. So we have like a sliding counterweight inside that, moves forward and backwards to like give the pitch, but we don't have like static pitch control.
And then what's your tether? This is like 4x4 brain, like literal like bumper winch brain, but like, do you have a metal line or do you have like a synthetic line? Like
what is the tether?
Yeah. What is the tether?
So the tether that we're working with right now is a Blue Robotics. It's like a polyethylene coated like Cat5. So if you think like your generic Ethernet cable, but that will sink in water, right? So they put like a jacket. At first they put a Kevlar jacket so you can actually like yank on it to get your unit back. And then outside of that, they put like a specific amount of material to give it neutral buoyancy, which is super important.
Yeah, that's cool. It's like a climbing rope, where you have like a core of something, and then a lot of the protection is the sheath around. Just in the sense that it's layered.
Yeah, it's like that, except it's static. Your climbing rope is going to have a give to it, so you don't like break your back after you fall.
Are you a manufacturer drowning in orders, juggling inventory and procurement data across multiple systems, or managing production manually? then you may want to take a look at today's sponsor, DOS. DOS is an adaptive ERP that kills implementation hell by working directly with your team, connecting all your systems to minimize data entry so you can focus on production. Instead of barging in like a bull in a china shop, they take a deep look at your actual operations and they build a system that matches how you operate today, placing only the parts that need improving rather than trying to fix what's already working great. Does that sound like a team that you could actually enjoy working with? If so, head over to DOS.com, DOSS.com, use the link in the show notes, or tell them that Joel from Tool or Die sent you. DOS.com, one platform, total visibility.
But
how did you get roped up, no pun intended, with this company?
So, yeah. So a little bit of my background. So I did I ran like an IT company for, I don't know, 7 years or something. And then I kind of saw the writing on the wall. So I got into industrial robotics. So I was like a hired gun industrial controls tech, designing assembly lines, process engineering, building like assembly cells for automotive OEMs in the area. And then I didn't see the, like, how should I put this? So like
You clogged your toilet
Yeah.
and you called a plumber, and the plumber's brother was like, "Hey, I know these people who I need your help."
So what happened was like, my family, they're farming in Iowa, right? And I started like putting thought into, hey, how do I, I'm going to inherit like large swaths of land. What am I going to do with this, right? And I sat down and I started like crunching the numbers, like, can you make money like as a farmer nowadays? Well, the answer is no. So I was like, all right, well, AI is starting to come on board. We got this like next generation of like robots. And it's like, I want to take a swing at making the next generation of agricultural robots. Okay. So I got into school at U of M in the robotics program. So I'm a graduate student down there. And then I started, as part of that, you have to like pick a group. U of M only has one field robotics group. That's Dr. Skinner's group. So I joined that group and I was working on submarines, and then
U of M farm is in Iowa. I don't know if you forgot.
Yeah. So I was building these submarines, but I wanted to learn like, how do you do a startup? This is not something I know. So I got really involved with the Center for Entrepreneurship up there and like the venture capital groups and like starting to wrap my mind around that. And then that's when Elliot was looking for somebody like, hey, I need somebody who has experience building submarines and has some like management experience and like knows how to like execute. And that's when I got hooked up with him. So as soon as we got hooked up, I took over this particular role, and like I've kind of shifted more into like the submarines, both on like the academic sense and then also in like the business sense, working with Elliot.
And how long ago was that? Like, how long have you been part of it?
About a year now. Yep.
So you guys already have some either paying customers or pilot program customers, right?
Yep. So we got another pilot coming up in July. So we're going to be working with Detroit and getting...
Like City of Detroit.
City of Detroit, yep. Looking at a couple of water mains out there.
And that's what, in all honesty, like I'm not that interested in the business model, not because it's not a critical thing for a company, but I feel like yours is fairly obvious. It's like find people who manage your own pipes and then give them some value. But how much on the data side? Well, actually, let me go back to hardware. I keep skipping over the hardware stuff. Your sensor package on the robot, like, is it all visual? Like, what is the sensor package?
Sure. So we are testing like a whole bunch of different sensors. First and foremost is visual. So we have like a camera in the front that like looks forward, and we use it for, gathering visual data, right? Secondarily, we have acoustics. So we can hear when you're going down the pipe, like if there's water rushing in and out.
Yeah.
And then from there, we've got ultrasonic sensors mounted on. So we can like record the signals from like how the edges of the pipes look. And then that also helps with like our centering algorithms and stuff. Beyond that, we have like any number of like sensor packages that we can deploy along.
You're not doing chemistry like things at the moment.
I mean, we can. It's not,
you could put whatever.
Yeah, 100%. Yeah. So we have like on the outside of the shell or on the outside of the hull, we have I call it like a saddle, but we have like a set of like mounting ports, so we can mount whatever we want on the outside as long as it can withstand 100 psi, which is like basically.
Can you have it put a little picture of Robert Kennedy tree next to it that says "I hate fluoride" or not?
Yeah, exactly. We could probably make that happen. Like have a little paper cutout that goes thumbs up, thumbs down if there's fluoride present.
I wanted to know about the sensor stuff. Although, as an aside, like it's very interesting in a lot of the robotics and automation companies that I talk to, where and we know tons of people out of AV because we worked in that industry for the last 10 years. And, you have all these fancy sensors and sensors getting cheaper and better, and there's new categories of things coming. But it's crazy how much, especially in the machine learning discipline and compute increases, where people are like, camera. Like camera, actually, we can do it a ton with visual now that we turns out we don't need as many sensors. The reason I was asked about the sensors, though, before asking about the business is like, you're talking about how in a water-rich state like Michigan, or like a lot of, from here east, basically don't have problems really. The way that a lot of these cities have tended to treat their infrastructure is like, a little leak is no big deal, or that's a problem for like the next administration or decade. But at these scales, we're still talking sometimes like, hundreds of thousands of gallons over the course of a year that could weep out of a pipe that's still 99% whole. Like, I'm making up the 100,000, but like on the modeling side for where the value of the company is, like what's in a broad stroke, like what kind of money saving and time saving can your robots actually give to the DO, whatever, the departments of I'm like departments of pipe. It's like whoever's actually managing those.
Yep. So we have a couple different like revenue streams in some of them that we're exploring right now is like trying to understand like if there is a break, can we go and like inspect and see like how far the problem is, right? Because these municipalities, like there'll be a break and then they say, okay, well, we got to bid this out. So they say, we're going to bid out this chunk of pipe. Well, if something happened and it's like an acute issue right on that one piece of pipe, contract signed, they're replacing that whole pipe. Right. So we can offer them savings by pinpointing exactly how much pipe needs to be replaced in that particular issue. Right. Beyond that, like we can give estimations on like how much time a given pipe has left. So if they say, hey, we want to go check out this like the pipe, we go out and look at it and say, all right, well, you can probably get like 5 to 10 years and here's why, that's good for them. Another problem is like they don't know what they have a lot of times. So if you go look at, some like Detroit has like an okay handle on like what water assets they have. But if you go look at like Houston's GIS systems, it's like they have an incredibly detailed map of like what pipes are where, right? So when you start talking about where like how big the pipes are, this makes a big difference when you're talking about where can they support further development. Right.
Yeah, I talked to some Verizon people over a decade ago, but when they were rolling out a lot of FiOS in New York City, and the stat that always stuck in my head is laying fiber in New York City was 5x minimum or 10x often because of when they put a shovel in, they had no idea what was underneath,
right?
Because it's an old city and it's been rebuilt, and every technological, from indoor plumbing all the way up to fiber optic had been another layer, and they like literally just didn't know what they were going to get. And of course they couldn't disrupt anything to lay their pipes. And while New York City is the densest city in the US, like there's a lot of places of the older cities that, they just probably don't even know what they have. And on top of it, there are still, I don't remember where exactly, probably in New York to some extent in Boston, there are still like functioning water mains that are like wooden in some places, because it turns out they were able to, make it for 150 years and they were able to get through. So just even being able to build a map of your water assets has to be just that alone has a lot of value.
Absolutely.
Yeah. Speed wise, because you're still sending a robot down a pipe.
Yep.
And it's only going to go so fast and it goes so long. But if you were to project out, like let's use Detroit as an example, because you probably have at least a good mental model of that. Like Would that be something using the Motmot bots? Is that something that would take like a decade? Is that something that would take like a year? I'm not even saying that's the model or that's a good idea, but just to get a sense of like how big.
No, I mean, so it's really like a radius problem. So Detroit is kind of a special case because, like, you know, we just have this ring of like kind of, you know, it's not very heavily populated in some areas, but the infrastructure is still there, right? And that was actually part of the problem when it came to Flint. Flint used to be this incredibly bustling town.
Yeah.
And part of the reason that the lead was like such an issue, beyond all the stuff that has already been discussed, is that the pipes are so big that the water moves very, very slowly inside of those pipes, right?
Yeah.
So there's it's not only like if your water system's too small, like the water pressure dips down, it's also if it's too big, like it doesn't flush.
Yeah, people, I didn't know until I lived in Detroit, or I didn't clock it, but like the part of the problem with a lot of the Rust Belt cities in general, there's got to be a better name than Rust Belt. I apologize every time I say it. I don't mean it disparagingly, but like Detroit, the stat for me that made everything click was like the population of Detroit peaked in like 1925.
Yeah.
And so in square footage, yeah, it's hemmed in by the river and everything, but like in the lakes, but it's like, it was big. And then the population decreased. I don't know what it is now, but it's like a third of what the peak population was. So part of the reason Detroit in the down times, it had all the housing and, you know, all of that era that everybody knows about is unique to Detroit in a like square miles situation where it's just like literally the city was built for 1 million people and now only like 400,000 people live here.
Right.
But those pipes still, for the city to operate, there are still some people that live in even those little pockets.
Yep.
And so the water has to work and the sewage has to work, but they don't have like the tax revenue to do it. So any efficiencies have to be welcome.
Yep. Yeah. And I think there was a lot I think water is only a part of that, but there was discussion at one point if they could like pay people to like move out of areas so that they could just say like, okay, well, we're not going to municipally serve it in this area. Right. Yeah, right. Yeah, if you have like, you know, 100 people per square mile in some like areas of Detroit, it's like, geez, well, there's still 80,000 streetlights. He kept talking.
Yeah, there's another aspect that's come up when I've been talking to some of the robotics companies this week in Detroit, where, you know, I still have a lot of skepticism about the future, which is a bad attitude, I suppose, if I were just being an evangelist. But I'm just trying to, I want it, but I want it to like actually happen, and I want to be realistic.
Yeah.
But a little switch that happened to me this week is on some like ARBs and delivery robots type stuff, where in my head I'm always like, well, in a certain urban density maybe, but somebody was pointing out to me that it was like, well, actually Detroit's a really great example where like delivery robots could be really good because you have some people who didn't want to move, who are now in food deserts or like service deserts, but you know, getting another robot to go over there is much more likely than having like human delivery.
Yeah, DoorDash. Yeah.
Do it. Same with cabs and busing and transit. Like when you are, do you have plans to like, you're starting with a 6-inch like pipe diameter as the target? Does that get you like 80% of a lot of municipal water, or is there variance in regions?
Yeah, it's 8 inches like what we're shooting for right now. Okay. And then, 8-inch would cover the vast majority.
And what is the default that goes in now? Like 8-inch, like cast iron? Is that like still the standard, or like what if you're a new city putting in water?
So 8-inch PVC going into like a neighborhood, and then it's like it scales up from there. So to get a good flavor on that, again, I would say like take a look at Houston's GIS systems, because you can see, you know, basically everywhere where they're putting in the roads, like the water is underneath there. So you get this like big grid, and then it's like every single pipe is like.
Do they tend to, like in Houston specifically, I would, maybe other people do it too, like is the water line under the asphalt, like literally under the road, or is it running parallel, like in a ditch effectively, or a sidewalk?
I mean, it depends. Okay. So, but you know, generally speaking, because it's a municipal service, they would want to put it inside of the municipal right away, so that if they need to get to it.
I'm just literally thinking about servicing, you know, like somebody had to sit down and go, I'd rather shut down a street, or I'd rather shut down a sidewalk. And I was just curious.
Yeah. I think it depends on like the jurisdiction and like how they laid it out originally. But a big thing to remember is if you're servicing these old lines, like especially, you know, where you got a little bit more space, is the roads tend to grow out, right? So it may have been next to the road originally, but hey, we got to add 2 more lanes onto this, and now it's under the road.
So on the modeling side, like, what sort of data are you capturing to start to give life cycle projections?
So that's what we're looking at, the visual data, like trying to look at the growths that are growing, the tuberculation coming in. And then we're also the acoustics, being able to track down those individual leaks.
Say that word again.
The acoustics?
No, a tuberculation.
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 So if you go look, this is an interesting thing. We found when we were running like decommissioned water lines is, I know you were kind of pinging at like the software side, but an important part of the software is like, you got to keep your robot centered, right? And the reason is, those TikTok videos where it's like somebody turns on the tap and it's like brown stuff comes out and I'm like, I'm supposed to drink this. Yeah. That's already in the pipe. It just got knocked off for one reason or another. So when you're going through these pipes, like there's actually huge areas of like buildup, right? And as that like builds up, that will inhibit the flow. But you also, like, if you knock that off, like it immediately clouds the pipe, so you can't see anything, right?
Yeah.
So that's a big part of the decay of those pipes is like that infill as like the sediment builds up and there's like corrosion depending on the water chemistry and all this kind of stuff. But like the pipes actually get smaller with time as well.
The tuberculation.
Yep.
Sorry, I just love words. If you've ever cut a pipe in half, like a water pipe or whatever, like the water chemistry makes a difference, but you'll usually see like a copper pipe or something like that. It's just rings. It's like a tree. And then inside you'll see usually white, which I think is calcium. And then like things will start to build up. And that's why a pipe often ends up clogging over time. It's just because the minerals have attached, or in a case of like a cast iron or something like that, it's corroded, and that first layer of corrosion is almost like a protective barrier, but if you then knock that off, it's just that oxidation is going to happen again.
Exactly.
So your model is basically like, you need to know pipe and material life cycle, and then you can, as long as you don't bang the sides and make the water cloudy, largely through visual inspection. Is that like, do you run that through like a ML model, or is it more of just like a look at the picture and you can kind of know?
Right now we're doing basically look at the picture. We don't have like a big enough data set to be able to generate like the AI models, and it's like being able to identify the different I will get to the point where like the ML will catch up to like what the engineers can tell just by looking at it, but like we don't have enough data at this point to support that sort of like training.
You don't need it right now because you're just putting a camera somewhere that it hasn't been before, and that's a huge amount of value.
Exactly. You got it.
But we're just curious because trying to think, like Matt Pukalski, Bucket Robotics, Raj from Intermode, they're doing a lot of like process and finish inspection. And one of the things, just on a geeky side of things, that I think is so cool is they're still largely using visual, but they can start to build models of like how the light is reflecting off of like a piece of stainless to learn some, get some insight about like tension or like interior defects, which is cool. But I want to pivot a little bit, because I do think what Motmot is doing is logical and cool and makes a ton of sense. But I want to go back to your robotics impetus is ag, and like tell me a little bit, first of all, like your family from what part of Iowa?
Right outside Iowa City, so Oxford, Iowa.
Is like this largely a corn and soybean and whatever is
row crop. So yeah, my family farm is the kind of place, you know what time it is based off of the sound of the car driving by. So it's off the beaten path, quite a bit.
Your plan is overall, unless you strike it rich, building robots is like your long-term plan is still like to go back to the farm at some point just to take that, carry it forward.
Yeah, I just when I started having my own kids, I just started putting more thought into like, what am I feeding my kids, right? I did some gardening or whatever, but like the farm I live on now, like I really started planting orchards and growing food and doing all that kind of stuff.
Here in Michigan, you have some more land.
Yeah. I think but Motmot follows that same impetus. Like I want to know my kids are drinking clean water, and it's like we want to supply the whole community with that clean water, right? I think on the agricultural side, like it doesn't matter, Michigan is the number 4 horticultural exporter, like in the country state wise, and we have a good climate for it. We have good soil. The primary problem that we run into is like the labor supply, right? So one of the reasons that California does so good growing is they have that Mediterranean, climate, but they also have cheap labor that they're importing across the border. And it's like, it doesn't matter if you're importing cheap labor from across the border or if we're just importing, Dressley berries from wherever. Like our food supply is hinging on cheap labor no matter what.
Same question, but just to give you a little more context, it's like what I want to know is your opinion on automation and robotics in farming in particular. And for reference, like for somebody who grew up on a farm, I would not call myself a farm kid to you, but compared to everybody else, like I'm a summer farm kid, right?
Yeah,
like Bale Day and was in and
out
all over the time. And and I'm from the Ozarks and have family up and down Missouri.
Yep.
And when I was a kid, half my family are farmers and half were like radio engineers. Like that's my family.
Yep.
But like I've only got 2 parts of my family that still are holding. They may hold the land, but that are still holding any land in farming. And I'm very pro robotics and automation. I'm a little anti the John Deere model, but in theory, because of the labor issues and also because of pesticides and a bunch of that stuff. But just give me your 10,000 foot view on if you were to turn around tomorrow and not engineer stuff yourself on the industry itself for ag automation, like where do you see things working and not working?
So I think agriculture is one of the areas where we have there's an incipient golden age. And the reason I say that is because the automation that we have been dumping into agriculture has been really in support of like furthering row crop, right? And then if you think about like even the automation that bleeds down into horticultural products like blueberries, it's usually like focused in only on blueberries. So people who come into the country from the city, they're driving through these big fields and they're like, oh, everything's green, it's beautiful, it's this, is that. But like if you look at your average species per acre, it's like 2. You know what I mean? It's a war zone in terms of biodiversity. And it's only been getting worse as like, these farms are being bought up by these big conglomerates. Yep. And then the big conglomerates are saying like, we're putting in subsoil tile. So all of those like nice grassy places where the pheasant could hang out, like that's all gone. They rip out all the fences. They farm to the road. Every square inch is making money for them. So it's like whatever biodiversity was out in that area is like really going downhill. What I think is the path forward is like if you can get automation into the fields in such a way that like you can give flexibility to not only like your big farmers, but also like dive down into your like CSA. Like I think there's a lot of room to move in terms of like diversifying not only the crops that are grown in these like smaller family farms, but also like moving the food supply, the production into the cities or closer to them, right? They talk about vertical farming. One thing, I joined the Michigan Climate Venture up at University of Michigan, and I was the leader for one of the food ag teams. And it's like looking through the news and the autopsies that they're conducting on these vertical farmings. These vertical farms, the golden age was like 2020, but they all went belly up, right? Did you hear about the one that Bezos, was it Plenty? I think Plenty just had some sort of trouble too. But it's you're always going to compete with, if you're trying on the vertical farming side, these plants want to be outside.
The vertical farming stuff, like, the sci-fi like nerd in me is like, cool, try it, let's go. When I see some of the stats just on a supply side of because the vertical farms are basically just hydroponics, and hydroponics is fairly solid science,
right?
And but one of the things that people don't actually, because of marijuana being legalized, I think a lot more people have a cursory understanding of hydroponics. Like hydroponics is a closed system and you can really optimize growth, but like you're still having to manage pest and mold and all of these things. It's not like it's it's not like if you take a plant out of nature, like you don't have to use chemicals or all those other things. You may have more discrete control over it.
Right.
But then, yeah, the vertical farm stuff, I really want that to work. But yeah, in the business right now, it doesn't seem to be clearing. And a lot of it is because just their output, their throughput hasn't been as high as they anticipated. Like their cap cost or their OPEX has been way higher than they had thought. I still think there's something to it, but to me, that's like, it's probably more at like the CSA gardening scale than it is
100%.
like an industrial scale.
Yep.
But I want to go back because you connected two things I love, but like now I'm like all solar punk. I'm like, wait, this could be awesome. I'm sure you're familiar. Some listeners may be familiar, but probably the most influential farmer of our lifetimes is a guy named Joel Salatin, who wrote, I don't remember what his first book was, but he's often refers to himself as a grass farmer. And reasonable people, especially with the farming community, have different opinions about him because he was never a row crop guy or whatever.
Right.
But to set up a little bit of the context, like your family, my family, the kind of farms they had, row crops, which is just generally grains or things that can be processed and are often in bulk, right? So like a lot of part of the Midwest grows a ton of soybeans. Well, why do we grow soybeans? Because we don't eat that much tofu. Well, one is export. We for a long time exported a ton of soybeans overseas where they ate it more, but also like we grow a lot of pork, and guess what we feed the pork to grow? A bunch of soybeans. And so there is that sort of thing, and it is very mechanized, but for the family-owned farms, to a great extent, like they just basically, the market and or the government tells them, this is what you're growing this year because of pricing or whatever. And when you hear about farm subsidies, and to be clear, there's a bunch of farmers that abuse the subsidy system like that. There is, waste in there. But by and large, the system is, another way I'd put it is, I have a couple of farm families, family of mine that are farmers that I would say are millionaires for part of the year.
Yeah.
Where it's like, if you look at the bank account at some point, it's like, hey, we have $1 million in it. And then they spend $950,000 getting the crop in,
Exactly.
like doing all that stuff. So you have that. And then on the other side, you have like Joel Salatin, who is a grass farmer, and getting to the diversity part. It's not just because it's cute to have a little blueberry and a couple of pigs and your cows doing this and your whatever. The soil, and it's not necessarily just organic, although it overlays that. Like, it's a system. It's like your different animals and your different crops all feed each other and feed the soil. The reason a lot of people don't do it is because it takes a ton of labor and the yield is bad.
Right. And couple that, people just look at farming and they assume you go buy some seeds, you throw it in the ground, and when it's ready, you go take it out and you take it to market and sell it. And that's not how it works at all. So, each one of the different crops that they're putting in, like when you go buy seed, you're taking in a whole bunch of different factors, whether it's like, am I planting late? So I need to get like an early harvest type of corn. Another thing that you had brought up, like, why do we plant soy? We plant soy because of the reasons that you had listed, but also because it's nitrogen fixation. So the next time that we plant, like, we don't need to put as much nitrogen on the corn, right? Corn is incredibly nitrogen intensive. That level of expertise, and that's something that I've run into, is it's like, oh, I want to put it in this like cute orchard. So I got like apples and like cherries and peaches and plums and all this kind of stuff. And it's like, okay, well, the plum curculio is going to wipe out my plum. So I got to spray for that. But I still have petals on my cherry tree. So if I spray for this, if there's any overspray, I'm going to nuke my beehives, right? So having to, each different crop has its own set of like expertise that goes with it. What do I need to look out for in terms of pests? What do I need to look out for in terms of like fungus or like, what activities need to happen? And I think that's one spot where automation and AI can really help out.
Well, because I would boil it down to, everybody thinks it's like robots picking strawberries, and that's a factor, but it's also just new tools. Like nothing will make you become a person that uses Roundup faster than trying to grow a little bit of food in the scenario that we said, where you're like, oh, and I'm not like pro herbicides and all that stuff in my home. I'd use it for some things, but like by and large, I try not to. But it's like, there's a reason that stuff exists, and it has a role, and to a great extent, yes, the root cause is that we don't grow enough of our food in smaller plots, and where there could be overlap, and hey, I lost my plums, but your plums came in great, let's trade. But a lot of it is just like the set of tools. And within robotics and automation, one of the things that's really cool is like, don't think about the robot and automation, think about what the tool at the end of that robot is. It might be a laser, it might be a UV gun or whatever, which would never be deployed at scale if humans had to do it, but automation could.
Yeah, and I think like that was like my original pitch when I was coming back to grad school for like these agricultural things. It was like, I want to develop platforms that can support like robotics departments across the country to like develop those tools. I think one reason that like ag robots is like, it's a harder thing than most is because you think about the growing season, like right when it's getting started, that's when the students are all leaving. So there's like not that many classes that are really like glommed onto
about that.
And then, when harvest comes around, that's when the farmers don't want the students out there messing around because like, yeah, this is where we make our money, right? And then on the other side of that is like, how do we the problems that are encompass like how do you if you want to develop a tool for like one reason or another, you need like a test bed, right? But because like the agricultural robotics programs right now, they're generating like they'll do drones, which are fine, but the drones like they can go spray basically, they can do inspection, but they can't like pick anything, right? I mean, there's some like the Israeli startups with like the drone apple pickers or whatever, but on the other side you have like the rovers, but the rovers have their own problems where it's like they have to be charged, right? These programs generally aren't going to invest in like the $1 million John Deere tractor, and even if you do, like it's going to take you years to develop something to hang off of the back of that thing. And that's assuming that John Deere is going to play ball in the first place, right? So I think there's a lot of motion trying to build platforms and get it into the university so that the universities can like support the hunger that's there. And I'm telling you that as like, I was the like GSI, like the TA, the grad student instructor for Deep Rob, which is like the one of the capstone AI courses in robotics for teaching robots how to like see things. Every semester, you got kids love ag. They love it.
Yeah.
But it's just like nobody wants to bite. Nobody's there. And then you fold that on top of what you were talking about. It's like, it's not only the subsidies thing, but we have the extension system. So in Michigan, MSU is our extension, right? And MSU has some engineering stuff going on, but like, man, in terms of like the engineering resources, like U of M is like next level, but nobody wants to touch it because they know the USDA ain't going to be sending them any money because MSU is the designated extension, right?
It's for a certain type of person, and I'm one of them. It's like ag robotics is one of the kind of green, I was to say greenfield, like open sectors. It's like, man, there's so much money there that and efficiencies is the name of the game on all of it. It's all
right.
Just bushel price, so
yeah.
There's so much room there to grow. And I just wish more people wish more kids that aren't farm kids would clock how rewarding that work is, because you get to watch more stuff grow and be outside,
right,
and move dirt around. Like, it's really fun work.
Yeah. And I think honestly, like people feel better. I mean, my wife busts me up a little bit because it's like I like to go outside and like thin peaches or whatever. I got dirt like embedded in my hands, but I just feel better getting outside and like doing some physical labor, right? And I think that agricultural automation, like because of the ability to embed like these novel robotic platforms with like high level like AI models that aren't that hard to generate, like it's really setting the stage for a situation where it's like we can have like interchangeable tooling on these machines that can allow us to like do blueberries and strawberries and something else. And I think the other thing is like as people you got like putting the politics to the side of like the Maha movement, right? When you have like the populace starting to take like a much closer view of the food that they're eating, and you're starting to see companies like Oishi popping up where it's like, hey, we're going to sell you strawberries, but they're selling you strawberries in like a clamshell and it's like $1 per strawberry, but that strawberry is going to be perfect. And it's going to be the best strawberry you ever eat. And I think it's a novelty, but it's also addressing like a core issue of you want a blueberry. What do you want in your blueberry? What do you want? What is the best blueberry that I can sell you?
The one where the farmer used a ton of sulfur.
Okay. Yeah. Acid soil. But like you want something that tastes like a blueberry. You want something that looks palatable, right? You want something that's sweet. You want something that's juicy and everything else. Me as the farmer, what do I want to sell you? Well, you're not going to taste my product before you buy it. So I want something I'm selling to you on volume. So I want the biggest blueberries. I want the blueberries that are going to not get destroyed during harvest. So I want them tough. I want them to be able to hold on through the processing chain. Right. So there's a big disconnect into like what I want to sell you and what you want to buy, which is why the strawberries nowadays are the size of baseballs, but like they don't taste like anything.
And they're white inside.
Right.
It's also because, and let's get back to reindustrialization, like, and man, Maha too, and all of the Make America Healthy and all of it. There's such a cultural thing now that's so wild to me as like a, like leftist, 90s anarchist kid, seeing a lot and like hippie adjacent or whatever. And then like seeing a bunch of the right-wing people paying attention to these things, and I'm glad they like organics and the foods and all of that stuff, and what they and we are all putting in our bodies. I wish they didn't also then bring that skepticism to literally everything, like vaccines and everything else. Like science is still the core and should be the core of this. Question the science always. That's what science is. Nevertheless, what I also think is a vision that you're outlining, and that I wish I don't know, people maybe will get it, is like to use your strawberry example. The reason the strawberries are like that, everything you said, also it's because like you want strawberries all year. Well, we have to ship them in from Guatemala, and so some of it is everything gets picked early, and so that it can go through the shipping process for however many weeks. The answer to that is not like a bucolic hippie dream of like, well, I'm only going to buy from farmers markets and
Right.
people around the road. That's great, like that's cool, like that we need more of that too, and we should support small farming. But the real answer, the American answer to me, should be like, oh, okay, we need to continue to improve this whole process. We're going to make growing things locally that can get delivered to stores faster. Let's fix the middle of the problem and make a better version of the supply chain for that food.
Yeah, but this is also where like AI and ML comes in, right? Because if I'm a blueberry farmer and I'm like planting different types of blueberries, so it's like, okay, well, I'm going to do like Duke blueberries. I'm going to do Patriot blueberries for like whatever reason. It's like my blueberry beds that I have on my farm are planted from like earliest ripening to latest ripening. So it's saying, it's not even, you can get blueberries for a very, very long time.
Yeah.
If you have the ability to like spread out the different like types of blueberries that you're planting, right? And apples are like the same way. Peaches the same way. So it's like we can extend like our harvesting, but the farmers aren't going to be willing to do that because the labor that comes in like picks, it's like they're coming through, like you're picking this day. If it's ready, it's ready. If it's not, maybe you can delay it once, but like you got to get that crop out of there.
That's a huge, like in commercial farming, like I mean, yes, labor is a factor in it, but it's also just like it's just harder work to layer all of that stuff in. Like, there's as a very rare farm kid that lives and has lived in New York City for most of my adult life. There's a bunch of times when somebody will say to me, I just want to get away from all this and just do something easy like farming.
Isn't that crazy?
And I'm like, what you want is a fucking garden.
Yeah.
And I support the garden. It's actually gardening's harder than you think it is too. But it's like there's no easy farming, and the reason that the wades of blueberries or whatever that you're doing, and a lot of people don't do that at scale, is it's very regimented on these commercial farms where it's like, this is planting, this is now harvest, and these are like couple of week windows because they have to optimize for other problems that may happen, water, some blight, whatever it might be. They don't have the luxury to like layer in all this stuff, but you're absolutely right. Like machine tools, AI, all of that stuff can do it. Moreover, I even like I don't even know why I'm obsessed with this, except I think I'm a little autistic. I'm sure it's part of it. But I always think about my entire adult life, I've been like, landfills drive me nuts because both for the consumerism part, like we shouldn't be throwing so much stuff away,
Right.
but also because I'm literally like, is Waste Management, the company, going to be like the biggest company in America as soon as robots can go open those landfills up and safely like remove stuff out? There's a bunch of big civilization scale problems that are I'm most energetic about AI and small robotics, because there's a ton of problems that can be solved where no amount of humans will ever do it, but a fleet of like 1 million very simple robots given a decade could fix some of these larger scale problems.
Yeah, that is an interesting question. Like, if we take an old school landfill, like the landfills that they turn into parks or whatever, right? So it's like, what is, if labor and energy were zero in the perfect world, what is the value of the materials that you could extract out of an old school landfill?
In my town, the original landfill is on a peninsula that juts out into the Hudson River, and they've turned it into a nice little park, and good on them. This is the same river that like you can't eat the fish out of because of the PCBs from Kodak 70 years ago or whatever it was. But like, I look at that all the time, and like they did the best they could. Like, I'm glad they did something with it. But yeah, I literally look at it like I'm a dwarf, like driving by a mountain being like, there's gold in there, like there's mithril, but I don't know. And I don't think a lot of people know. But yeah, if the energy supply could get to the point, the other factor of that is like, because energy, another framing, like people have asked me recently, like, oh, you're all about reindustrialization, what's the most important industry we should be investing in? And I'm like, energy, like, because energy will help solve a lot of the other problems.
Yeah, I think energy is a big reason. If you look at like the vertical farming, like, why grow lettuce? Because lettuce doesn't require that much light to make a decent product, right? It's a low light crop.
Yeah. Quick turnaround.
Yeah, it takes like a lot of energy just to do any of this stuff. And even when you look at like agriculture, the energy is not going into like the diesel for driving the tractors around. It takes a lot of energy to run the Haber-Bosch process to generate the nitrogen that you have to put on the corn.
Yeah.
Right. So,
I mean, our modern food supply is petroleum based, and we could, because we get our nitrogen from that process.
Right.
We can fix it with 10 or 20x more global power.
Yeah.
But like, I don't know, man. A lot of this to me is a framing thing, which is like, I went to dinner with some Detroit friends last night, and we are talking about nukes, because I'm getting ready to go do a tour of a lot of the new like fission startups.
Yeah.
And it was the woman I was hanging out with grew up near I believe a plutonium mine, basically, or some sort of processing stage. And my friends, who are both very smarter than me, and more scientific backed than me, like were immediately going like, oh, Yucca Mountain didn't happen, and like, oh, like the water table problems for like all of this stuff. And my instinct is, because I'm a conservationist and a kind of left-wing skeptical of the government type,
Yeah.
And but something has really changed for me in the last couple of years, which is like a little more, I hope, prosaic or long-term thinking, which is like we may need to raise our risk profile a little to fix some of these bigger problems. But if you don't get inspired by the idea that maybe we can actually fix things, and you're just stuck in the idea that modernity sucks and it's just a slow decline into, a terrible like panopticon state, which is a possibility too. But it's like, to me, that is the spirit of a lot of the companies here and a lot of the companies all around the country that I'm talking to, which is like, just open your heart like this much and go, is a better future possible? And if your answer is all the way closed to no, I kind of don't have patience for you anymore.
Right. Yeah, I think, I am hopeful that like nuclear energy will be coming back on the table. I know this was a couple of years ago, but a contract that I took was to like evaluate the cybersecurity of these like big inverters, right? And as part of that, like I have like these giant inverters and these giant batteries, and I was like, well, I already have the expensive part, so maybe I should, the panels are cheap, I'll just put solar on my barn, right? And going through the process of trying to get that worked out was like an absolute nightmare. And it got to the point where it's like, okay, well, you got to go to DT has to sign off that like you can have this solar on your barn, right? So I call DTE, and then DTE is like, okay, well, we got this like magic formula where we're going to take all the electricity that you use over the year, and you can never be in the black, right? And then it's like, are you serious? Like, why would you not? And this was even after net metering. Like, they're only paying me generation, right? So, I got frustrated with this, and I called the Public Service Commission. I'm like, hey, they're telling me I can't like put solar in. And he's like, yeah, well, if everybody generates their own solar, like DT's going to go bankrupt. I was like, okay, well, that's bullshit. Because like,
it's not my problem. That's not everybody else's problem. It's a utility that existed and was created at a period of time. This is this is like a lot of what the Ezra and Derek's book about abundance. There's a lot of stuff in it, but basically finally levying the idea that is always a right-wing coded idea that like maybe there's too much regulation in process. And I understand why people are afraid of deregulation, because those things were generated to protect people. OSHA, like, the environment for like NEPA and a lot of those laws, like, yeah, keep our eyes on it. Like we don't want it abused. But the flip side is, it's almost like we just kind of like are trying to freeze like 1978 in amber and then go, that's the civilization that we want and we need to protect that forever. Like we can't allow people to put solar panels on their barn because like, what if it makes our bureaucracy fall apart?
Yeah, I think like the frustrating part of it is that what people are actually like up in arms about isn't necessarily like the regulation, right? If the regulation is like couched in like, yeah, we want your kids to be healthy. I mean, you're always going to be able to nitpick and be like, oh, these people don't want blah, 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 blah. But like that law is talking about where like, hey, they get to pick how big of a solar array you can put on. That law sunset, it's changed now, but like at the time, they didn't have to buy the power if they generated more than 1% of their electricity by buying it from people. So it's like, it's sunset automatically. So it's like, if I'm a Republican, it's my barn, I should be able to put one on it, right? And if I'm a Democrat, it's like the world's on fire and you should be paying me to put solar on my barn.
Yeah.
The only person that you're helping here is DTE. And that's the regulatory capture that like people need to like focus in, because that's the middle ground that like, that's the regulation that needs to be wiped out.
I think, and I have to grin and bear it sometimes when I find common cause with people that I kind of just don't like them in their personality, but I am trying to be an adult and look at a lot of this stuff, and it really is the lens for me is distills down to a better future is possible, not on the off-world colonies.
Right.
Like,
yeah,
a better future is possible. Let's waste as little time as possible debating it, because I'm tired of debate, and we've been stuck in debate for like 20 or 30 years.
Yeah.
Like, this country in particular has one path. We set the template last century. We exported that template to China. They picked it up, innovated in some ways. They're doing great off of that template. We don't go back to the 20th century playbook again. We take all the lessons that we can learn and we build a new template. And it is not, I have a ton of American exceptionalism energy. It is not out of just pure jingoistic, like, white cloths and like 4x4 energy. It's like a lot of it is honestly like just very statistical on one hand, which is like big ass country, tons of amazing natural resources. I mean, we're within a stone's throw distant now of the biggest freshwater supply on this hemisphere, like in the Great Lakes.
Right.
We've got the stuff to do it. Just the same reason in the 20th century we were able to stand up so much industry. All of the facts and figures are on our side and continue to be on our side. And what we have also, and maybe has been a little too mixed up, is I do also, and this is where can you queue up a American Eagle but use a red-tailed hawk scream, because that's actually the noise that they need to make. Like, I do genuinely believe and have believed for my whole life, and I am a person that didn't want to believe this as like a 90s kid, but like then when I started going around the world or whatever, I'm like, Americans get shit done, and it's like those two things together are great, but I'm tired of having debates with anybody else about, oh, it can't be possible. I'm trying to find the people that are going to go try it.
Yeah, I think I had my mom worked for Ford, right? And like at the time, to get ahead and forward, like she had to take a international service assignment. So like I lived with her in middle school in Budapest, Hungary, which was like less than a decade after like the wall fell. Yeah. It's like I was there when they got their first like mire. And it's like, I think a big cure for doomerism in the United States, unfortunately, is like just travel more and like travel off the beaten path. So you can see like what, I'm not saying that everywhere is terrible, but like there are a lot of terrible places on this planet, and like you should have like a full like experience of the spectrum also possibilities before you start trashing what you have.
Need context.
Right.
Like I grew up I'm from the Ozarks, went to high school in Kansas City, but I'm from Missouri. Could not wait to get out of Missouri and moved to New York in my early 20s, and loved New York, and it was awesome. New York was totally different experience than what I had imagined it would be. A good one, but it was a different thing. But what it also did is make me turn around and go, oh man, I love Missouri too. Yeah. Like, and there's lots of stuff Missouri needs to fix and has done. But in my lifetime, Kansas City in particular has been this amazing example of like, I left in, 2002 or something like that. And then when I go back to Kansas City now, I'm like, well, if you guys would have told me you were going to get cool, like maybe I wouldn't have left. Like, right. Kansas City is an awesome city now. And like that point, I agree, world travel and all that stuff is also super useful, but it's like, that's what we need more of, is like less of I don't like the America versus everybody without a little bit of introspection, because we have tons of stuff we should be working on. But the left-wing perception and kind of messaging for a long time, I don't know, well, the last 20 years or so has been like, America's not so great. We have all these problems, and like, we need to keep that in mind. And there's a time for that. That's the introspection time. But we got mired down in that. It's like, what you also can do, the same message and the same ideas go, yeah, America has a lot of problems, and no, we shouldn't like pretend that's not the case. So let's fix the problems. Right. And like, let's move forward on this stuff. Let's not get stuck. And I that's why Tool or Die like ended up kind of just absorbing my entire life in the last couple of months, is because I'm like, I see it, and I'm meeting people like you. I'm meeting other people who I'm like, oh, I need to stop just bitching, and I like need to do my little tiny part to try to figure out like, how do we make the vision of America that's like not what it was in the past. Same thing I always say about Detroit. I never want to hear a story about like, Detroit's long legacy of whatever. Like, I don't care. Right. What's happening? Oh, pipes that go into the sewers and the water supply. That's Detroit. I want right. that. I want that story to.
Yeah, and I think like I appreciate that, because it really like it puts a fine point on like the what you're talking about, which is like the reindustrialization. Is like, how do we get people to focus on like moving forward and like doing big projects? Yeah, right. I went to lunch with somebody recently, and they were kind of like pointing out like, yeah, our culture's like kind of lame, like we don't build big things anymore. Yeah. And I think we still like, we do step back and say like, oh, that was an amazing achievement or whatever else. But like as a society, we don't really like focus in and like do dangerous stuff, do like border case stuff. You know what I mean? But maybe it's just we're getting kind of stale because we don't have that like impetus. Maybe China chomping at our heels is going to be a good thing to like wake up and like focus on some of the more important things.
I am familiar with a bunch of projects that got kicked off after COVID when the supply chain stopped. Yep. In medical supply in particular, and some sort of basic resources that have still not, even with government funding, started. And I say that not to say to be hopeless, but if COVID, just on a supply chain thing, didn't cause a lot of this to move, and, with the current threats of China and Russia, which like, who knows how much of a threat any of that really is. Yeah. It's like, I'm saying this mostly to the people that are already in it, in reindustrialization and like trying to reestablish manufacturing, trying to fix the big problems that create new big opportunities in the U.S. is like, the people that are in this don't expect everybody else in the country to like go, yeah, awesome. Like not everybody's going to be on it until they see it. Most people, even Americans, are risk averse, and they're not going to take on big problems until they do it. The only asterisk I put next to it is like, we can do crazy things that we've never done before, and we can also do them thinking about safety and equity, and however you want to, or equality, however you in whatever vector you want to talk about. Like it can be both, but like you got to just actually believe in a future, and if you don't, look for the other people that believe that future is possible.
Yeah, I think following up on that too is I think there's room. Yeah, Detroit's interesting, right? Because we're based around like the car companies, but like the car companies have that same like kind of staleness to them, where it's like, hey, why? People complain. Why does a pickup truck cost like $80,000, right? And it's like because there's like these regulations, so they want to jam as much content into these vehicles as possible, but if you don't need that, it's like, it's frustrating because more than anything, like I would love one of those little Japanese like trucks, the ones I'm talking about.
Yeah.
But you can't buy them. Well, Slate, because they're too dangerous. But I can go buy an R1 and embed myself in the corner of a building.
You can buy a motorcycle and ride without a helmet in half the countries. Like, it's come up a couple times, but it's probably worth being like the OEMs and the auto industry here in Detroit. Most of those companies I have friends at, and like and in full support, but they are like, that is the Detroit story writ large, which is Detroit should be about manufacturing, not about cars, and the future of Detroit is not automotive. The end. Yeah. So like the where I push when I can to the automotive companies is that message to say like, man, you guys have so much, but there's no innovation EV or product or anything. Like there's only so many units to sell at this point, and people don't need that many cars. But what Michigan has, especially like all of Michigan writ large, and Ohio and a lot of the other states, is capacity and engineering skill.
Yep.
And like I think you're a great example of it. I think a lot of the people I've talked to this week are a huge example of it. But like we do need to, I'm looking for the first automotive CEO that gets up and goes, the future of our company, like, we're going to keep making cars, but the future of our company is like, we're going to be the arsenal of reindustrialization. And so we're going to start making drone motors, and we're going to start figuring out, we're going to throw some financing money behind some job shops to take on new high mix stuff that they normally wouldn't build. Like that should be the role of the big three moving forward. And we'll see if I can guilt them into it.
So you see the big three moving into like the Hyundai model. Like Hyundai makes all sorts of crazy stuff, right? It's the same thing.
I don't know, in like a kind of all under one family chaebol, or however you say that Korean word, like that model. Although, if you look at the history of like Frigidaire, is maybe still like, but like the early days, that's early Detroit, right? Is like manufacturing in general, and then the auto industry just was kind of formed the tip of the sphere eventually, because they were pioneering a new category.
Yeah.
It's not that necessarily. I actually think the auto companies still, if I were in my corporate strategist mode, I'd be like, stick to your knitting, just get really good at cars. Right. I wrote a piece and we will be done soon, I swear to God. I wrote a piece recently when Slate came out, the electric truck startup. I don't know where they're based.
Rivian?
No. This is brand new. It's called Slate.
Oh, okay.
That Bezos threw some money in, but I don't think he's like the main thing. But they basically went, everybody wants a simple pickup truck. We're building a 2-door pickup truck. You can add a bunch of shit to it. You don't even have to have a center stack. Like you don't even necessarily have nav if you don't want it. It's EV based, but we're doing EV because that's the right powertrain, but like we're not worried about that either. And with the subsidies that will probably now get kicked off, they were aiming for like $20,000 as their entry price. But without subsidies, it'll be like $30,000 or whatever.
Yeah.
But their approach was the approach that really made sense for automotive. Anyway, I don't want to get like stuck in the car stuff so much, but it's like, to me, it is New Lab is part of Michigan Central, which was funded almost entirely by Ford family, stuff.
Yeah.
And that's good. It's a good thing. Like the best thing that can happen with the money and talent and connections and even at a national and global stage, what I'm trying to say is I think the automotive companies should be not just like creating the first step of innovate or helping the first step of innovation in Michigan and Detroit happen. I think they need to be helping at every stage. So if Motmot needs, like right now you're buying your platform from another company, right?
Right. Yeah. The components.
Yeah, which is fine, like for you guys for where you're at. But I guess that's what I'm saying is components. Like I think Michigan and the auto companies should be leading this. And electric motors are specifically like what I've been talking to the leadership of these companies about this week, where I'm going, you're selling a bunch of EVs, they have electric motors in them. Meanwhile, when I go to a defense forum and everybody's freaking out that we don't build enough drones and are going to the domestic drone suppliers and saying, hey, you may need to get ready to build millions of drones if for whatever reason that becomes a near-term warfare platform. And those American companies are going, cool, happy to do it. No one makes the electric motors at the size and scale and efficiencies inside of a domestic supply chain. Can you help me fix that? And DoD people and stuff are working on those problems. But I look at that whole problem and I go, sure seems like General Motors could maybe figure out for, the same amount of money that they put into a bunch of other pilot programs, they could just say, we're going to make a new standard of electric motors in these 7 sizes. We'll work with people to establish that standard. Then we're going to bootstrap that by, saying, sorry, Bosch, we love you, but we're going to have to, in some of our cars in the wiper motors, start using these because we need to test the lines or whatever. And then also go around to all of their suppliers, especially the ones, domestically in the US, and say, we're going to do lead gen or whatever. We're going to connect you to all those companies, but just pick, to me, it's like sniping. And that's what I'd like Detroit to do right now at a component level. And they thought they were going to do it with batteries, and then it keeps getting screwed up. I don't want to get into why that is. It's sort of getting there. But I just look at that part to me is where Michigan, as led by the auto companies, could really affect reindustrialization positively, is to be like motors, carbon fiber, like just pick something and go, we're going to bring that 100% here. We'll work it into our products to make sure that it stands up, but we're also going to not give it away, but as close to cost as possible, figure out how to get that into the domestic supply chain, because that immediately would cause a bunch of new industries and companies to happen in Detroit and outside of Detroit that would then all still be operating within a domestic supply chain.
Yeah, I think, and the drill, baby drill, like that mentality will probably help support that too. Because I know, part of the problem when it comes to the motors is we don't have the rare earths.
Yeah.
Or it's like we do, but we don't make them here, right?
We pull them, MP's pulling them out is the only rare earth mine that I'm aware of, but still shipping, I think, to China for processing.
Right.
I mean, that's a Fed level thing that I would like to see, although maybe it's better for states. Like I was in full support of the CHIPS Act and Build Back Better in the broadest strokes.
Yeah.
Like the one thing that people, we got to figure this part out too. It's like China figured out or was able to get up to speed in the way they were because of a command economy where they went, we're investing in this for a decade. Okay, cool. It's stood up. Now we're pulling back and we're investing over here. There needs to be a few, I haven't said this publicly, but like I have this idea that I, just as an organizing principle that I keep coming back to, which is one of each, which is like, maybe we're not going to have textiles back here compared to India or Bangladesh or Korea for, woven cotton, but we should have one woven cotton plant, like shovel to shelf or whatever, like full supply chain. Let's stand up one of those. And there's not every industry that we need to do it. My initial analog is like looking at the way the St. Louis Fed divides like the manufacturing categories,
right?
And just be like, we should have one complete supply chain in example in each of those categories. Nitrile gloves is another thing I'm looking into right now, where the government cut, and he's going to kill me because I forget the name of the project, but the government cut out a bunch of stuff even before COVID to try to onshore a nitrile glove plant because we were importing effectively 100% of that.
Right.
Got the half of the government funded, unlocked enough to build a factory in Virginia for that. And then during COVID, the other half of money got clawed back, which was the part to buy all of the raw material and set up the workforce or whatever. So we have the U.S. has a perfectly functioning nitrile glove factory sitting in stasis, basically, with spending money to keep it, the machines and the real estate and the property and everything a good nick. Nitrile gloves during a pandemic in manufacturing. Like, we need nitrile gloves. Now, am I saying we should become the global home of nitrile gloves? No. Like, that's not necessarily a good idea either. But I can't believe after COVID, after war threats, after the chaos of the tariffs, no matter whatever it is, that people are not the people who can actually make some of these things happen are not moving at light speed to try to figure out, just for pure resiliency for a future pandemic or a future war, how to onshore some of this stuff. And that is where the capital markets, venture, a lot of things, there are people that are trying to figure that out. But that to me is also a really great use of federal level money and power, which is, and because I'm super socialist, or actually I'm just very utilitarian, I'm like, I'll use whatever model will work. I don't care if those things are federalized for 10 years to stand them up and then they get sold into a private, market again or whatever. But I just can't believe we're talking about it so much and not building. And so that's what I'm saying. But like, we need to be able to, Kastner's is another one. Like, I have a bunch of people back channeling to me because they think I'm more connected than I am. And they're like, hey, by the way, do you know anybody who can make like these screws and this material at this thread pitch? And I'm like, no, I'm pretty sure no one in the US can. Like, that's the level of problems that I would like to see Detroit and Michigan leadership in the financial centers, like power brokers, taking a look at. Because they don't need to look at it like we're going to become the global market of fasteners, but they could go, what if we had enough that if we lost the shipping supply chain for 6 months, everything wouldn't collapse?
Right. No, that makes sense. Yeah.
Do I have your vote as I run for King of Michigan? No.
Yeah, absolutely. Yeah.
No, I mean, look, I have sympathy. These are hard problems. Everybody disagrees, but like on the implementation, but I think reducing them down to the simplest thing is what I'm trying to do, and then we'll see if I'm right or not. But I've really enjoyed the conversation. I really appreciate the time. It's great to meet you, and I would like to, when you guys do a little more of the pilot testing and things, like come back and I really want to know like where the efficiencies are at, like the robot itself, all of that, like how it's done is also super interesting and compelling.
Yeah.
But like, I bet you guys are going to discover a bunch of really cool insights of like, we didn't think there'd be efficiencies here, and it turns out there's a ton.
Yeah. No. Yeah. Well, I'll hit you up. I'll send you like some information if you want to come like shadow us when we're doing our pilots or whatever, and we can get you some of the like the inside the pipe video footage, because it is pretty impressive.
It'll be my Katie Couric moment.
Yeah.
Like,
yeah. No, absolutely.
All right. Thanks for coming on, Tulid. Talk to you soon.
Yep. Thank you.